Hello, my name is Shay Shelby, and I'm a product manager on the Imagery and Remote Sensing team at Esri. And together with my colleagues Jay Zhang and Dave Wright, we'll be introducing you to ArcGIS Image for ArcGIS Online. I'll begin today's session by giving a high-level overview of a new way to manage and analyze imagery in ArcGIS Online, followed by Jay and Dave, who will be going more in depth on these new and powerful imagery capabilities that we are very excited to introduce to you. Today, we'll be examining scenarios in wildfire and agriculture to demonstrate the power, efficiency, and convenience of ArcGIS Image for ArcGIS Online for the management and analysis of your imagery, terrain, and other raster data. These new capabilities enable new geospatial insights through raster analysis, including multidimensional variables and deep learning, all conducted and hosted within your ArcGIS Online organization. The ArcGIS Image product suite quickly integrates imagery into all of your workflows. It empowers an organization to host, analyze, and stream imagery and raster collections from their desktop, on-premises, or in the cloud. Run image analysis and raster analytics at site, city, country, and global scales. Extract insights by performing analysis, including classification, multidimensional, and advanced AI workflows. Share the insights you gain with internal and external stakeholders as interactive apps, dashboards, and reports to drive faster and more effective decision-making. Most of you are familiar with the current deployments of ArcGIS Image, ArcGIS Image Analyst for ArcGIS Pro, and ArcGIS Image Server for ArcGIS Enterprise. Today, we'll be introducing you to a new SaaS deployment of ArcGIS Image, ArcGIS Image for ArcGIS Online, while briefly touching upon ArcGIS Image Dedicated. So managing imagery is difficult. A lot of money is spent on buying imagery, but how do you make sure it's used? How do you make sure the imagery is accessible? Well, you typically need to set up infrastructure, find a way to store and manage that information. And then maybe you want to share it across your organization or to external users. And then what if you want to analyze that data? What if you want to create information, answer questions, or create derivatives from that imagery data? Well, ArcGIS Image for ArcGIS Online provides that solution. It makes imagery accessible. You can serve imagery and raster data to all of your users, internal or external. It simplifies imagery management. You can manage all your imagery and rasters within ArcGIS Online. It eliminates the need for infrastructure. You can host, analyze, and stream imagery and raster data without needing to deploy and manage infrastructure. It helps you stay within your budget. You can save on infrastructure costs and maintenance using a secure, scalable, and performant cloud environment managed by Esri. And lastly, it allows you to run analysis on your imagery inside of ArcGIS Online, perform powerful interpretation, image, and raster analytic workflows at scale. With ArcGIS Image for ArcGIS Online, you are able to simplify image management and scale raster analytics as a SaaS. You are able to host, analyze, and stream your imagery and raster data via the cloud. Organizations are able to host and manage imagery in ArcGIS Online. It supports all forms of imagery and rasters, standard projections, and multiple metadata sensors and collection platforms. Host your own imagery or other partner content, whether it's satellite, aerial, drone, orthomosaics, terrain, multidimensional, and more. And to ensure your images are ready to use, the metadata associated with your imagery remains intact. With that imagery you've hosted, you have the ability to use image and raster analytics at scale for classification, multidimensional, and AI workflows. Users can perform image analysis in ArcGIS Online using more than 150 raster functions, more than 20 ready-to-use raster analytics tools, and pre-trained deep learning models. ArcGIS Image for ArcGIS Online can help organizations to assess suitability, which lets users detect variability across the Earth's surface, such as differences in terrain, elevation, land cover, and visibility. Detect change, where users can apply deep learning to streamline change detection workflows. Inspect assets, where organizations can upload images of assets and infrastructure, then apply image processing and analysis to evaluate the conditions of those assets. Monitor vegetation, which can help users examine multiband imagery to extract information about vegetation coverage. Trace water flow, which allows users to locate watersheds, which are areas that contribute water that flows downstream. And lastly, plan routes and networks by allowing users to analyze imagery to identify the optimal paths and connections between areas. For streaming, leverage ArcGIS dissemination capabilities to reach all your users and directly integrate imagery into your existing geospatial workflows. Stream imagery of large construction sites, cityscapes, and entire regions, as well as post-event imagery, rectified scenes, orthomosaics, elevation, multidimensional, or categorical rasters. You can also stream the results of your imagery analysis to your entire organization. Users can then access and stream the imagery and raster data in other applications, dashboards, story maps, and reports available in ArcGIS. So let's review what you can do with ArcGIS Image for ArcGIS Online. You can host your imagery in Esri's cloud, upload and share your imagery and raster collections in ArcGIS Online, making them accessible to those users who need it. But if your imagery data is already in the cloud, or you're looking to move your imagery data to the cloud, ArcGIS Image Dedicated would be a good option to explore. It has the same general capabilities as ArcGIS Image for ArcGIS Online, but it's for those organizations whose data is stored in AWS or Azure. ArcGIS Image for ArcGIS Online lets you create ready-to-use image services. Intelligent, tiled, and dynamic image services provide immediate pixel-based analysis capabilities in web and desktop applications. Extract insights from all kinds of imagery. Interpret and extract information from yours or other imagery and raster data sets. And lastly, share your imagery products. Quickly go from imagery to storytelling. Turn observations, analysis results, and subsets of dynamic or tiled imagery into interactive apps and dashboards anyone can understand. And with that, I will now turn it over to Jay, who will be talking about hosting imagery in ArcGIS Image for ArcGIS Online. Thank you.
Thanks, Jay, for the introduction of this new exciting product. Next, David and I will dive into the details of capabilities offered by ArcGIS Imagery for ArcGIS Online, starting from the ability to host imagery data. Once you sign up for ArcGIS Imagery for ArcGIS Online, you will have the ability to upload your imagery data from your local storage to ArcGIS Online's hosted data store and create hosted imagery layers. And there are two new types of imagery layers that is supported by ArcGIS Imagery for ArcGIS Online: the tile imagery layer and the dynamic imagery layer. Comparing to the traditional tile layer, which already exists in ArcGIS Online, and you may be familiar with, the two new imagery layers have many advantages. The traditional tile layer can only serve pre-computed static tiles, which is 1 or 3-band JPEG PNG files. It is commonly used as base map layer for fast visualization, but it also has obvious limitations, such as it cannot be used for analysis. In contrast, the new tile imagery layers while also serve static tiles, but it can also support multi-band imagery with more than 3 bands at full pixel depths and even multi-dimensional raster data, which makes it fast for visualization and at the same time suitable for image analysis. This is achieved by automatically optimizing uploaded image data to a new tile format during the layer creation. And because of this optimized format, web client can also be enhanced to perform client-side rendering and the reprojection on this type of layer. And if you need additional functionality, such as server-side on-the-fly image processing and dynamic image mosaicing of image collections, then dynamic image layer is your choice. Dynamic image layer is supported by the latest release of image server running in ArcGIS Online. It provides a powerful server-side processing capability and also put less load on the client. And because it's image service, same image service as in ArcGIS Enterprise, the layer is well supported by all ArcGIS applications. If you have an existing tile image layer that you want to utilize the additional functionality of dynamic image layers, the tile image layer can also be republished as a new dynamic image layer item. With the built-in layer creation user experience, you have 4 different ways to create image layers with ArcGIS Imagery for ArcGIS Online. You can either upload a single image dataset and then publish that dataset as a single imagery layer, or if you have a collection of imagery layers, you can either decide to publish them separately as multiple imagery layer, or mosaic all of the imagery data together into a single image and publish the mosaic image as a single image layer. Or if you want to preserve the original data format of your uploaded data and take advantage of dynamic image layers, dynamic mosaicing capability, you can choose the image collection mode to create a dynamic image layer referencing the collection of image data. And ArcGIS Imagery for ArcGIS Online also support a variety of different type of image data formats. You can upload conventional image file formats such as TIFF, JPEG, PNGs, or you can create layers from scientific multidimensional data such as SDF, GRIB, or NetCDF. And we also support 30 different types of satellite data sensors and aerial sensors. As I mentioned earlier, when you decide to create image layers from a single image data, and the imagery data will be converted, and you have the option to choose either to use JPEG or lower compressions to compress your data. Or if you want to preserve the original upload imagery format, and you can choose the serve as image collection mode. There's also additional settings allow you to customize the metadata information of the image layers such as pixel units, acquisition date, column map, attribute table, vertical coordinate system, etc. Now let's look at a quick demo on how easy you can bring your local imagery data to ArcGIS Online with our built in create image layer wizard on the web. Once you sign into the organization with ArcGIS Imagery for ArcGIS Online enabled, and your user was also granted with necessary privilege to use the functionality, you can navigate to the content page and click on the new item options. In the pop-up new item dialog, you'll find imagery layer option becomes available. Click on image layer option will bring you to the create imagery layer wizard. The first page of the wizard will ask which type of imagery layer you want to create. You can either create tile, dynamic, or both from the uploaded imagery data. We already talked about the difference between the two types of layers. In this example, I'm going to go ahead and choose tile imagery layer. And the second page asks which mode you want to create your image layer. If you upload a single imagery, it's straightforward. You can just choose the one image mode, which will create one image layer from this single image, a single uploaded image. Or if you're uploading a collection of imagery, you can either choose to publish each imagery in the collection as separate layers, or you can mosaic all the imagery together to create a mosaic image and publish the mosaic imagery as the final tile imagery layer. I'm going to choose the one mosaic image mode and click on next. And now you go to, now it comes to the upload dialog where you can browse and or drag and drop imagery files from your local folder. In this example, I'm going to just upload 2 TIFF files. And once the files has been put into this upload dialog, it will start uploading. And on top of the upload dialog, you'll see the imagery type drop-down list. For the conventional file format, like what I was uploading here, choose the raster dataset data type is enough. If you're uploading scientific data or satellite or aerial camera data, you need to choose the data type appropriately. In addition to those, you can also choose the tile image layer data type, which can create a new tile image layer from existing one or many tile image layer that was created and owned by your user. And below the data type drop-down list, you can also find configure property options. Click on the button, it will bring up additional options you can configure during the layer creation process. For example, under General tab, I'm uploading the 2 TIFF file I'm uploading are actually color map image. I can choose my source type to thematic. I can also choose the compression method I want to use. For the color map image, low compression is enough. Or if you are uploading RGB natural color image, it is recommended to use a JPEG to further compress the data and save the storage cost on the tile imagery layer. And because I have choose the source type as thematic, I have additional options where it allows me to specify additional color map input for the data I'm uploading. I can choose the color map file, and then there's other options you can configure, such as metadata information about the acquisition date of the data, band mappings, or spatial reference of the output layers, and the data transformation you want to use if your input data is different from the target layers projections. And there's also additional processing options such as building footprint or define no data value for the pixels for the imageries you're uploading. Once you finish configuring those options, click on Apply, and then click on Next. You can define the layer name and the tag to create the layer. And click on Create. It will finish uploading and start converting the TIFF files to and mosaicing them together to this tile format, optimized tile format. Now let's look at what other options you have if you choose the dynamic imagery layers. If you choose dynamic image layer on top of the three creation mode that is available under the tile image layer option, you also get the image collection mode. In this image collection mode, you can upload a collection of imagery data and then preserve its original format and create an image collection and publish the collection, publish the dynamic collection as the dynamic imagery layers. The upload dialog and data type drop-down list is the same as what we saw on the tile image layer options. And one thing to be noticed here is, say that if you're uploading satellite data, it is important to upload the entire folder contains the satellite scenes. By preserving the folder structure of the satellite scenes, you can create the layer successfully. And the rest is the same. You can define the layer name, assign a tag, and then create. This concludes my create imagery layer demo. Once you have the layer item created, specific to dynamic image layers, you'll find additional options under the items details page. For example, you can go to the settings tab of the item detail page and configure additional settings for the dynamic image layers. You can define the request size limitations, just like the settings available for the enterprise image server. You can also define additional processing function template attached to a specific dynamic image layer items. And for the dynamic image layer that is referencing the image collection, you also have access to additional post-processing tools under the image management tab. You can build footprint, build overviews, compute scene lines, color corrections, etc. These are specific tools that works on image collections. Now, once you have created imagery layers, the next thing is to talk about the enhancement we made on streaming or rendering the imagery layers. For tile image layer, our web client can support client-side rendering such as projection, tree relief, and color map renders. We are continuing to expand our web API to support more client-side renders for super fast visualization. And as of today, the tile image layer is supported in the classic and new web map viewers, the scene viewers, and also ArcGIS Pro, but the version has to be 2.6 and up. And for the dynamic imagery layers, because it is actually image service behind the scene, one signature ability is to support the server-side on-the-fly processing, either through the built-in processing template or any last function processing template that is shared in your organizations. And dynamic image layer is well supported in all ArcGIS applications, including our classic and new web map viewers, the scene viewers, all versions of ArcGIS desktop apps, such as ArcMap and ArcGIS Pro, and also in the runtime SDK. And besides the ability to support image collections, if dynamic image layer is created from a single imagery through the one mosaic mode or multiple layer mode or one image mode, it is also referencing the special tile format and it can also support Tile API for fast renderings. Now next I will hand it over to Dave, and he will show you some demos on fast streaming or rendering of imagery layers and some on-the-fly processing examples.
Thank you, Jay. Let's compare and contrast the streaming and rendering experience for the layer types you and Shay have been describing. To begin, let's consider the client-side rendering and visualization available with tiled imagery layers related to the Cameron Peak fire. Here, I have an Airbus Spot 7 scene acquired last year on September 7th, about 3 weeks after the fire started. This fire was finally contained on December 2nd, but made its mark as the largest wildfire in Colorado history. This image is 60 kilometers wide, has 4 bands, and 16-bit pixel values as reflectance. Tiled imagery layers include all bands at the full pixel bit depth, which we can observe in the pop-up. Tiled imagery layers stream data to the client as CRF tiles containing all bands. Tiled imagery layers expose client-side rendering in the image display menu for compositing, stretching, and dynamic range. Changes are instantaneous and happening on the client side. Among the rendering options are RGB composite, stretch type, and gamma. Here, I have an elevation mosaic for the state of Colorado from USGS 1/3 arcsecond rasters, also as a tiled imagery layer. This elevation data aids in the understanding of fire progression and post-fire recovery efforts through its ability to provide slope, aspect, and terrain ruggedness. For terrain, there are additional rendering options, including shaded relief. Like the spot tiled imagery example, the rendering happens instantly on the client side. When working with a single band like terrain, the classify renderer is available, including the classification method, number of classes, and color ramp selector. It's important to address the unique visualization aspects associated with multidimensional raster data. Here I have a tiled imagery layer for surface weather and climatological summaries, or DayMet, covering Colorado from January 1st of 1980 to December 31st of 2018. This multidimensional raster contains daily time slices for multiple variables, including maximum and minimum air temperature, precipitation, snow water equivalent, and more. Like the other tiled imagery layers we've examined, the image display options support client-side rendering, including stretch type, method, classify, color ramp, and dynamic range adjustment. Let's continue the streaming and rendering comparison, now with dynamic imagery layers. Back to the Spot 7 data. Unlike tiled imagery layer, the image is streamed from the server for the entire map extent of the request. Instead of having tiles streamed containing all bands, we get only the bands or bands requested from the client. In this case, a true color composite computed on the server. We can still observe the full bit depth for all bands with the Identify tool. And the ability for custom rendering is also found. The result takes a moment as it's processed on the server and delivered for the client area. And we can also select the stretch type. Next, let's return to the Colorado elevation mosaic but this time as a dynamic imagery layer. The same visualization capabilities exist. For the elevation data, users can choose the shaded relief or the classify option specifying method and color ramp. Like the spot image comparison, with respect to streaming, the main difference is in how the result is streamed to the client. It's important to mention now that one of the most powerful capabilities unique to dynamic imagery layers is on-the-fly analysis, which we'll cover later in the analysis demonstration. So far, we've been using a web map for visualization. The scene viewer is another way to visualize and stream hosted imagery layers. Here, I'm viewing one of my post-fire imagery layers draped over the 3D terrain. Visualization is also supported in web apps, notebooks, and even ArcGIS Pro. Back to you, Jay.
Thanks, Dave. Next thing we want to talk about is the powerful analytic capability offered by ArcGIS Imagery for ArcGIS Online. Now, you already know that ArcGIS is a powerful platform for image analysis. We already have a super rich set of analytic functionalities offered through our APIs, our desktop applications, such as image classifications, deep learnings, spectral analysis, suitability analysis, and terrain analysis, multidimensional analysis. Nowadays, we are bringing all these analytic capabilities into ArcGIS Online. In the upcoming ArcGIS Imagery for ArcGIS Online release, we'll have raster analytic capability in ArcGIS Online, which includes 27 ready-to-use tools under the analysis pane on our web app, and including the deep learning tools with GPU support. And we also have over 160 different analytic functions. And through the function editors, it allows you to use the built-in functions to combine and train custom analytic workflows. And all these workflows can support tile image layer and dynamic image layer as input. It can also support output to tile or dynamic imagery layers. And we also offer a preview capability to let you see the analytic result on the fly before you spend credits to run and generate persistent analytic output. And the credit consumption of analysis jobs can also be pre-estimated before you run the task. I'll hand it over to Dave again for him to show you the analytic capabilities that is offered by ArcGIS Imagery for ArcGIS Online.
Thanks again, Jay. Before diving into the analysis demonstrations, let's first consider two important terms in ArcGIS Image Online: on-the-fly analysis and raster analysis. On-the-fly analysis requires a dynamic imagery layer type. The analysis methods are defined inside of a raster function template from the Living Atlas, from your ArcGIS Online organization members, or custom built using a library of more than 160 fundamental system raster functions. On-the-fly analysis is a powerful technique for data exploration and model refinement to validate the output meets project goals. In contrast, raster analysis can be applied on either tiled imagery layer or dynamic imagery layer. Raster analysis persists its output as new hosted imagery layers, and users can choose tiled imagery or dynamic imagery layer type. Raster analysis also includes a powerful web-based raster function editor to customize your analysis, and a growing set of advanced image analysis tools that are ready to use on your imagery layers, all accessible from within a web map. Considering these two scenarios can be a helpful approach to understanding which hosted imagery layer type best supports your use cases. Let's return to the Cameron Peak fire scenario for some on-the-fly analysis using dynamic imagery layers. Within the image display options for the dynamic imagery layers, notice the blue Add button near the renderer control. This enables selection of a raster function template for on-the-fly analysis. I'd like to visualize both slope and aspect together using a template that's available in my organization. The function chain, which fully describes the processing, is sent to the server where the rendering takes place and the response sent back to the client. My layer is now dynamically processing all requests using this custom function chain. The result shows 8 different hues for the aspect direction, with color brightness increasing where slopes are greater. Raster functions can also be saved along with your dynamic imagery layer settings. Let's explore this capability using Sentinel-2 imagery for the post-fire conditions. Sentinel-2 imagery includes 12 separate bands, providing great diversity in image compositing and band indices through the visible, red edge, near and shortwave infrared spectrum. Using show item details, the layer's settings can be accessed, where raster function templates can be added. Thereafter, users of this layer will be able to quickly select and apply templates from the renderer control. Now let's explore raster analysis, which is truly a web-based image science laboratory to help you craft and evolve your analyses. The Perform Analysis button reveals the raster analysis capabilities, including 27 ready-to-use tools that deliver advanced analysis capabilities, including deep learning and multidimensional analysis. Raster analysis also includes the raster function editor, and 160 system raster functions that you can explore, add, configure, chain together, and save. Here, the raster function browser enables easy filtering and search for existing raster function templates. I'm loading into the editor a burn severity analysis that will use multiple bands from pre and post-fire Sentinel-2 imagery to map out severity classes. I can explore the functions in use, verify that the necessary variables will be exposed in the dialog, and check my class names, values, and colors. After committing to the analysis, the dialog is presented, including the pre-fire and post-fire variables I made public. I provide an output layer name and choose a hosted imagery layer type for the result. But before running the entire layer, I can show preview to verify the expected result. I can also specify whether to constrain processing of the new layer to the current map extent or not, and even estimate the credits that this analysis will consume. I'm now ready to run this analysis. To save us a few minutes, I've skipped ahead to the processed result, a new tiled imagery layer with the burn severity classes applied across the entire fire area. I'm going to run a separate analysis to demonstrate the power of multidimensional data in ArcGIS Online. Returning to the daymap layer, recall that we have daily slices spanning from 1980 to 2018. But as a part of fire recovery efforts, I'd like to have a precipitation forecast map for the coming months of rainfall. I'm loading another raster function template. that makes use of the generate trend and predict using trend system functions to estimate precipitation through the end of 2021. I've set the necessary parameters and run the analysis. Fast forwarding to the result once again, I now have a monthly aggregate of precipitation statewide for the rest of the year. Having maps of burn severity and estimated rainfall over the fire area can help greatly in the recovery effort. An image science laboratory wouldn't be complete without Python notebooks. So let's add one more layer to the picture using the ArcGIS API for Python. We start by importing necessary libraries and packages, prompt the user for their credentials to authenticate with ArcGIS Online, and then load the dynamic imagery layer for elevation. Next, we'll construct the terrain ruggedness index model in code. Apply the color map values for visualization, and now display it on the fly. Finally, we can publish a new tiled imagery layer using code and load it in the notebook. Back to you, Jay.
Thanks, Dave, for the cool analytic demo. Next, I want to quickly go through additional client support and API enhancement for ArcGIS Image for ArcGIS Online. As I mentioned earlier, ArcGIS Pro from version 2.6 and up will support display and working with both types of image layer, including tile and dynamic. In addition to that, you can also directly launch image analysis task utilizing the built-in raster function user experience in Pro to ArcGIS Online and creating the result as a new tile or dynamic imagery layer. And we have also enhanced our ArcGIS API for Python to support layer creation workflow, visualization workflow, and analytic function construction and on-the-fly processing workflows. And you can also execute the image analysis task to generate persist output. And our ArcGIS notebook running ArcGIS Online also contains the up-to-date ArcGIS API, ArcGIS Python API for image analysis support. And the analytic result can directly be shared as hosted feature or imagery layers, both tile or dynamic out of box. Now we have covered all these capabilities offered by ArcGIS Imagery for ArcGIS Online. Next is to talk about how you can enable this capability. As of today, the ArcGIS Imagery for ArcGIS Online is only available on the 6 different regions in the globe. There are 4 regions in the United States, 1 in Europe, and 1 in Australia. In order to enable the ArcGIS Imagery for ArcGIS Online, you will need to acquire the ArcGIS Imagery for ArcGIS Online user extension license. And the user extension license also has to work with compatible user types. The user types are Creator, GIS Professional, Advanced, Basic, and Standard. And on top of the user type extension license, you need to grant privilege to the organization user in order for them to use the API and access the user experience on the web. The built-in user roles such as administrator, publisher, and facilitator will receive the privilege automatically. And if you want to create a custom roles, the privilege to grant to the user for create image collection is under the content settings group. For creating host or hosted tile or hosted dynamic image layer, there are separate privileges. And if you want to enable the image analysis for the user, you should turn on both the publish hosted layers, hosted feature layers privilege, and also the image analysis privilege under the premium contents settings group. And the cost for ArcGIS Image for ArcGIS Online is generated by these following items: the user type extension license, the compatible user types, and the image storage. The image storage is the image data stored in ArcGIS Online's hosted data store. And the capabilities additional capabilities offered by dynamic image layer is the cost of that is computed by a tier-based plan based on the image count on every dynamic imagery layers. For the usage of Taiwan dynamic image layer, there's no additional cost. And for the image analysis, the credit cost is computed per analysis request. And the organization administrator have access to the general cost through the organization status page. You can see the imagery storage cost credits on tile imagery layers based on the imagery file size that is referenced by the tile image layer, and also the dynamic imagery layers, the information about this imagery storage consumption, and also the image count per layers. And the same information is also available on each imagery layer items. And the image analysis cost is also metered. And the image analysis task, before it runs, it will compute the estimated credit cost based on the number of pixels processed, number of feature processed, and number of bands. Dimension slices are also the factors that will affect the cost of this particular analysis task, and also the complexity of an analytic function template. And last, let's look at all these different options you have to serve imagery data in ArcGIS. ArcGIS still offers the traditional approach for you to set up your own ArcGIS enterprise and image server clusters to support publishing of dynamic image services and perform parallel raster analytic tasks. Now, with the introduction of ArcGIS Imagery for ArcGIS Online, you have the option not to manage your own server cluster, but simply just upload your image data to ArcGIS Online to create imagery layers and utilize the imagery storage offered by ArcGIS Online and perform image analysis at scale. Alternatively to ArcGIS Image for ArcGIS Online, we also have another SaaS offering called the ArcGIS Image Dedicate. The ArcGIS Image Dedicate offers more control on the backend servers that supports dynamic image server and perform raster analysis. And the services created by ArcGIS Imagery Dedicate can also be registered to ArcGIS Online and interact with ArcGIS Online services for image analysis. And we also committed to support open data standards. To learn more about ArcGIS Image for ArcGIS Online and ArcGIS Image Dedicated, please check out our product summary page. And there's also a lot of other imagery-related technical workshops available throughout the UC. Please check out these links for the topic that you're interested in. And thank you very much for your interest in attending our sessions. And we want your feedback. Please remember to submit the session surveys after the Q&A. Thank you very much, and we hope you enjoy the user conference this year. Now let's move on to question and answer session.
Okay. All right, thanks everyone for joining us today. We have a lot of questions to get through, so I think we're just going to go ahead and jump right in and try and get through as much of this as we can in the next 15 minutes. So let's start with this question for, let's see here. Let's start with a question for Shay. Shay, an anonymous person asks, is there a data cap for how much imagery can be hosted?
So there is no data cap for the amount of imagery you host in ArcGIS Image for ArcGIS Online. However, you want to be cognizant of the the charges, the 1.2 gigabytes per credit per month for imagery storage. But we also recommend that if you have a massive amount of imagery data, let's say 5 to 10 terabytes, we have another product called ArcGIS Image Dedicated that is made for handling really, really large imagery collections. And that would be stored in the cloud. So it just seems to be more cost effective once you hit that point. So no data cap, but if you have a ton of data, there might be better options.
All right, great. Thanks, Jay. Okay, Dave, I'm going to jump into the question that seems to be on a lot of people's minds. Can you talk a little bit about the consumption of credits and how it can be estimated?
You bet. Great question. And as Shay mentioned, for tiled imagery layers and dynamic imagery layers, there's a fundamental hosting credit cost. That's 1.2 credits per gigabyte per month. So that's probably the simplest one to calculate out of the gate. Secondarily, with regard to dynamic imagery layers, there is an additional charge on that that's just based on the number of images. So it can go anywhere from 10 up to 160 credits per day. And that's really just based on the number of images that are available there to be processed on the server side. Finally, if image analysis is part of your set of use cases, there's a broad range of credit consumption that can come in from a very simple raster function chain to a complex one. And so some of the tools that we demonstrated today are your friend on that. You have the ability to constrain your analysis to a subset or look at the entire data set together and then estimate your credit consumption right in the app.
Great, thanks. All right, Shay, can you talk a little bit about how to go about getting ArcGIS Image for ArcGIS Online? So is it included with your ArcGIS Online organization? Is it an additional license that's required?
So ArcGIS Image for ArcGIS Online will be an additional license you'll need to purchase. So you'll be able to purchase that license just like many other things in ArcGIS Online. But yes, it is an additional cost.
Great, okay. And then Jay, is downloadability going to be coming to ArcGIS Online, ArcGIS Image for ArcGIS Online?
So this is actually a frequent requested features for both tile and dynamic imagery layers. In the first release of ArcGIS Imagery for ArcGIS Online, which is where we are currently, download capability is not supported yet, but this is definitely something that we want to work on and have available in the future releases.
Okay. And then I think similarly, are user-defined custom Python raster functions supported?
Yeah, also a very good question, and also frequent requested features. So some of you may be creating your own analytic algorithms utilizing custom Python raster functions, which you can upload in your enterprise environment and attach it to the image service or use it for raster analysis. So this is also something we want to work on for ArcGIS Imagery for ArcGIS Online. In the future releases, currently is not, there's no option for you to upload those functions and utilize them at the moment.
Something to look forward to. Okay, Shay, can ArcGIS Image for ArcGIS Online replace the need for utilizing image server in ArcGIS Enterprise?
That's a really good question. And I know that we've had a lot of questions surrounding that. So think of ArcGIS Image for ArcGIS Online as just a new way to work with imagery inside of ArcGIS. So it won't replace traditional image server, but it will be able to give you these capabilities within ArcGIS Online without having to set up infrastructure. So it really depends on your need. And then again, I've mentioned ArcGIS Image Dedicated is also a new product. And so really, if you're working in ArcGIS Online, you don't want to set up infrastructure and you just want to kind of work with some imagery, drag and drop into a browser, ArcGIS Image for ArcGIS Online is your best bet, but it won't replace, the bread and butter, image server capabilities on-prem that we have right now.
Great. Okay. Jay, let's see, are the imagery layers produced with ArcGIS Image for ArcGIS Online, will they work in a disconnected environment? like in field maps, or are they strictly ArcGIS Online?
And that's actually a good question, but there's actually two parts in that question. One is whether the imagery layers you create in ArcGIS Online can be consumed by runtime-based apps, right? The answer is for that, if you have a live connection to these imagery layers to the internet, and the current runtime-based apps will be able to consume the dynamic imagery layer, but not yet the tile imagery layers. And on the other hand, if you want to bring those layers down for offline usage, this is also some new features we've been working on. Currently, it's not the runtime API itself does not support bring down the tile image layer or dynamic image layer for offline use yet. So it's something to look forward to as well. Yeah.
And while I've got you here, Christiane asks, can I upload a mosaic data set that's already been created instead of having ArcGIS Online create the mosaic from the individual rasters?
That's a great question. This is exactly something we are working on for the next upcoming release. So in the next release, you'll be able to just author your mosaic data sets in ArcGIS Pro, referencing the data as you have locally. And then through the Pro user experience, you can upload the mosaic data set itself with all the customization you made on the mosaic data sets, along with the data that it referenced to ArcGIS Online, and create a dynamic image layer out of that. And this is definitely something that we're actively working on, but currently it's not there yet. But just looking forward to the next release, you'll be available.
Great. All right, Shay, this user asks, can imagery from an AWS S3 bucket be used without having to download the imagery and then upload it to ArcGIS Online? So can you use imagery that's already in the cloud?
Yeah. I mentioned ArcGIS Image Dedicated earlier, and essentially that product is has been created to work with your imagery that you have stored in AWS or Azure. So if you do have imagery stored in the cloud already, then ArcGIS Image for ArcGIS Online might not be your best bet, but we do have a product that will give you these same capabilities, similar to Image Server, that will be able to kind of connect with your imagery in the cloud that you already have stored.
Okay, great. All right, Dave, this user asks, can Python notebooks be used to load images, even cloud raster format images?
Thanks, Emily. Yeah, that's a great question. And using the ArcGIS API for Python, you can fully exercise these capabilities, not only loading and analyzing, but even hosting new imagery layers and conducting all of the same kinds of capabilities that we've demonstrated in the web maps.
Great, thanks, Dave. Okay, Jay, Azine asks, can we upload imagery to ArcGIS Online with a command line interface, so programmatically?
So this is actually already been answered by Dave. So we do provide an API, which is the ArcGIS API for Python, that allows you to exercise the like scripting or programmatic workflow to create hosted image layer, including upload data, right? But essentially, you can also utilize other tools through the our developer documentation and through the through some API that gets you the data store connection information, and use the native Azure upload tool to upload your data as well.
Great. Okay, let's see. Dave, after you create an image collection, can you add more images to it later?
That's going to be a great feature when we're able to add it. Today, once you've created a hosted imagery layer, it's immutable. So you're going to need to make change, you're going to need to republish.
Okay, that's good to know. Let's see, I guess this is for Jay. Is caching supported for dynamic image layers?
So the caching API was actually automatically enabled for dynamic image layers. So throughout the presentation, you may notice there are different ways to create your imagery layers. While you're looking at different mode to create a dynamic image layer, there's one image mode, one mosaic image collection, and batch publishing, right? Only except the image collection creation mode, all the other mode actually convert your data to what we call the cloud raster format. And with this format, the caching API for the dynamic image layer is automatically enabled. So only with the exception of the image collection creation mode.
Okay, great. Okay, another question for you, Jay. If we were to upload a DEM, could we apply on-the-fly processing to derive slope, aspect, and hillshade layers? And would those consume credits?
Definitely, you can. So we do have a additional UI options when after you create a dynamic image layer, where it allows you to modify the settings of the imagery layers. One of the settings is to attach additional processing template, i.e. the raster functions, to the dynamic image layer. So you can definitely publish a DM dynamic image layer and create slope aspect functions template as the processing template of the dynamic image layer. And when you apply those on-the-fly processing template on the layer, it does not generate additional credit cost, right? On top of the storage cost that you should already considered for the dynamic image layer.
Great. Okay, let's see. Dave, do I need an ArcGIS image license to view imagery hosted in ArcGIS Online in dashboard or web apps?
No, viewing is not going to require the user type extension for ArcGIS Image Online. It's strictly for the creation of new hosted imagery layers or to conduct analysis in ArcGIS Online.
Okay, great. Okay, Jay, will the image collection support time sliders? So can it show 2018 imagery, 2019 imagery, then 2020 imagery, like a time-enabled feature layer?
The answer is yes. And not only the dynamic image layer that referencing an image collection can support time slider if the image collection has the time information, right? You can have multi-years, for example, you can have multi-years of Landsat data. When you create a image collection dynamic image layer, the time information is automatically put into the mosaic data set behind the scene. And therefore, the layer itself can support the time sliders. And not only that, but also you can create multidimensional raster, which has a time information as its multidimensional properties. And that with that kind of layers, even if it's tile image layers, you can also support time sliders.
Great. Okay, then another question for you, Jay. Do you support the full capabilities of mosaic data sets? So I would like a SaaS solution, but I also want the control that mosaic data sets give to color balance and composite drone imagery with aerial photos.
Right now, I think this question is referring to full capability of all different kind of operations you can do with a mosaic data set. If you're comparing with Pro today, ArcGIS Online actually doesn't provide all those different tools or user experience allow you to work with mosaic data set. We do have a limited set of tools that allow you to perform color balancing, generating sim lines, but it is just a subset of what we can do with Pro, right? And but eventually, once we support publishing mosaic data set directly from Pro, you will have all this capability to do your customization in Pro and then publish the mosaic data set by uploading it to ArcGIS Online. Yeah.
Okay. And then let's see. One more for you, Jay. You mentioned a multitude of image formats are available in ArcGIS Image for ArcGIS Online. Is the imagery stored in their native formats as hosted tile image services or CRF?
Yeah. So again, it depends on what kind of creation mode you choose when you're creating your hosted imagery layers, right? With only one exception, which is when you're creating a dynamic image layer with image collection mode, we will preserve the original uploaded data format. All the other creation mode will actually convert your uploaded imagery data to our optimized cloud format, what we call the cloud raster format.
Great. Okay. And here's one more question for Dave. How much does the CRF format compress? I assume it works with 3 and 4 band images.
Yes, so we can use 3 or 4 because CRF is going to encapsulate the entire data model. So we're also going to get all of the bit depth that's present within that input imagery. And as far as compression ratio, it really depends on the incoming raster content. So we can look to providing maybe some benchmarks around some well-known standards, like a striped TIFF, for example, and maybe a few other scenarios that could help gauge and understand the expected compression ratios.
Great. All right. Well, I think we're about out of time for questions. I know we didn't get to everything. We'll try and answer more if we can, just privately. And then if you still have a question, definitely reach out to any of the speakers or additional experts that are listed below the video by clicking on their tiles. We really appreciate your feedback. And we hope you'll complete the session survey via the link below this video window. The recording for the video should be available as soon as it's processed right back here. I think you can access it using the same URL you used to find this, this session. We really appreciate all of your attendance, and yeah, we look forward to talking with you more for WC. Thanks, everyone.
Thanks, everyone.
Thank you.